we're going to be looking at the velocity of an object undergoing simple harmonic motion. For the acceleration of an object undergoing simple harmonic motion to be directly proportional to negative displacement, then one possible solution is for the displacement as a function of time to equal this a cos omega t. So the velocity, which is defined as the rate of change of displacement, will be found by the differentiation of displacement as a function of time, and this will give minus omega a sine omega t. The acceleration of the object, where acceleration is defined as the rate of change of velocity, can be found by differentiating the velocity expression with respect to time, and this will give minus omega squared a cos omega t. And because a cos omega t is equal to the displacement, we can say that the acceleration is equal to minus omega squared x. Another possible solution for this equation is for the displacement to equal a sine omega t. And if we differentiate this expression with respect to time, we get velocity. And if we differentiate the velocity expression with respect to time, we get the acceleration. And because a sine omega t equals the displacement, we get a is equal to minus omega squared x. So I've just shown you that when the displacement is equal to a cos omega t, then the corresponding velocity will be equal to minus omega a sine omega t. Now, to get a relationship of velocity v in terms of displacement x, we first use this expression, sine squared omega t plus cos squared omega t equals 1. And if we times both sides by omega squared a squared, we get this. So you can see that this expression is equal to v squared, and the a squared cos squared omega t is equal to x squared. So this becomes this. If we rearrange the equation to make v the subject, we get this. And omega squared is common, so we can take it out, and that simplifies to v equals omega times the square root of a squared minus x squared. We'll also get this equation if we was to use the second solution for displacement and the corresponding velocity, where we would have omega squared x squared plus v squared will equal omega squared a squared. So at the equilibrium position, when the displacement is equal to 0, the velocity of the object will equal omega a, and so we have maximum velocity. And at maximum displacement, where the displacement is equal to the amplitude, then the velocity of the object will equal 0.